I am Gayatri, working as Assistant Professor in EC Department at SNS College of Technology. Today I am going to discuss about the topic AC circuits and parameters, their waveform and their average values, which is under the Unit 1 Electrical Circuits studied by first year students in the first semester. Before going to the topic, let's have some recall about the electricity and what are the alternating current versus direct current, and the waveform representation of AC circuits, which is in the form of sinusoidal, square and triangular wave. And coming to the representations of sinusoidal waveform in terms of average value and RMS value. Now we can have the topic for the discussion: why we need the AC circuits in the form of waveform, average value and RMS value, and the AC circuits waveform fundamentals, what is the time period and what is the amplitude in that AC circuits, and what are the parameters and terminologies used, and the real-time applications of AC circuits. First, the AC circuit parameter. The AC, which is the alternating current, nothing but which is the time varying voltage or current which is particularly varying in AC circuits. The AC circuits, which is normally represented in sinusoidal waveform, which is varying from 0 to 2 pi value. In between there will be a pi value. The AC parameter, which is in the form of first one will be sine and complex wave and triangular wave and square wave, and cosine wave also available in the AC circuits parameter. And coming to the parameter representation of AC circuits, the first one will be the average value. The average value is nothing but it is a waveform over the one complete cycle. It is representing in a DC circuits, it is represented as a equivalent DC value that produces the same effect. The average value is nothing but it is represented by 2 by pi into the peak value of full complete cycle. The peak value, which is nothing but it is a maximum value of that particular sinusoidal waveform. And mostly the sinusoidal waveform will be used in rectifier circuits to calculate their DC output. Then coming to the root mean square value, the root mean square, it is nothing but the effective value of RMS that produces the same heating effect as the DC signal. The RMS value, it is nothing but the peak value by root 2. And it is nothing, it is a value of 0.70 value, where from the sinusoidal waveform, the peak value which is represented by V peak, and the RMS value is represented by V RMS. It is half of the sinusoidal waveform. And coming to the AC circuits parameters, in empathy part, in empathy mapping of AC circuits, why we need of AC circuits is confusing part. Thinking that if I need to calculate the RMS value correctly, then we are need of our AC circuits. After analyzing in the empathy part, the define part, which is a goal to synthesize the insights from the empathy, which is understanding the pain points from the user and then finding the solution in the defined path. By in the defined path, we can get the problem from the empathy, and which is related to the Ohm's law, by applying Ohm's law, where which is V is equal to I into R. And coming to the real world applications of AC waves and parameters, the first one will be the power distribution and electronic circuits and rectifier. In the power distribution circuit, maximally the sinusoidal waveform, it is used in power grids to efficient transmission of AC circuits over the long distance. And in terms of electronics, the square and triangular waveform, which is used in the stable multivibrator, and in mostly to derive the digital circuits. And rectifier part, it is classified into half wave, full wave rectifier and bridge rectifier. The half wave, which is using only one diode, full wave 2 diode, and bridge rectifier, which is using 4 diodes, and it is used to converting the AC into the DC circuits. And let us summarize the topic what we have discussed now. The AC circuits, average value, RMS value, and what are the different types of AC circuits analysis: square wave, triangular wave, and complex waves. And coming to the assessment question, which one of the following is not a AC waveform? The first one, sinusoidal, square, consonants and triangle. The sinusoidal waveform, it is a AC, square is a constant, which is the option C is the correct answer. And triangular, it is a form of AC. And coming to the second question, what does EMF stands for? The EMF stands for electromagnetic force. Option C is correct for the first question. Option B is correct for second question. And these are the references. And thank you. Thank you for listening.